Good morning and good morning to everyone present here. I am KARPAGALAKSHMI. I am doing MCA in Tech. My project title is Time Synchronization based on slow flooding in wireless sensor network. The abstract is the accurate and efficient operation of many applications in wireless sensor network requires the synchronization of time. So, the time synchronization is the process of fetching the time information from other systems on a network. An application in a network needs same time information for all clients connected in the network to avoid conflicts. In order to achieve the accurate time synchronization, we are using some techniques and protocols in this project. We discuss about the clock speed agreement algorithm used in this experiment. Our experiment results indicate that the efficient and accuracy of time synchronization and scalability of flooding. The existing system of this project uses the FTSP algorithm, that is flooding time synchronization protocol, was introduced to achieve the time synchronization. Due to the slow flooding, rapid flooding approach is proposed in the literature. The rapid flooding approach allows nodes to synchronize time as quickly as possible. The rapid flooding technique is also be slow due to the node that cannot propagate until their neighbors have finished their transmissions. Then the proposed system contains the flooding with clock speed agreement algorithm. It is used to achieve the accurate time synchronization. The FCSA forces all the nodes in the network to accept the clock speed algorithm to run at the same speed. The clock skew is eliminated by all nodes following a stable time. The accurate time synchronization and scalability of flooding is achieved. Advantages is eliminated clock skew, accurate time synchronization for all nodes in the network. Data can be sent at user defined time interval for all nodes in the network. Scalability of flooding is achieved, and communication between nodes in the wireless sensor network is easy and fast. Hardware requirements is the processor is dual core model and hard disk contain 40 GB, monitor is 15 VGA color, RAM 512 MB, others are wireless router. Software requirement, the OS is Windows family, language is Java and backend is SQL, editors NetBeans. The architecture diagram contains the server and the client. The server is connected with 3 clients and the request is sent to the server, and the server responds to the client at the time synchronization. While responding, it will calculate the time. Then the client response is achieved through the server. The time synchronization is accurate and easy and efficient for the clients to use the information and to fetch the information from the server. The modules contain building a network. First of all, in this module, we are going to build a network. We can build a network with more than one computer by interconnecting via wireless router. Here we are using 2 systems as server and the 3 systems as client, like in the architecture diagram. So the 3 clients will be interconnected with the 2 servers for communication, setting a default port ID for the network in the server system, and this port ID will be used in client system to connect with server. The time synchronization, each client nodes in the network might running in different speed and following different times. So we want to make clients to follow same time information. For that, we need to fetch the time information from all clients. The process of fetching the time information from clients is the time synchronization. The clock speed agreement is used to achieve the accurate time synchronization in this project. After finishing time synchronization, the server will send the clock speed agreement to all the clients. That is, each client should accept the agreement to run at the same time. In flooding with clock speed agreement is the proposed system. FCSA working based on clock speed agreement, that is the whole network follows the clock speed agreement. So all the client nodes will be changed at the same time as its system time. Flooding time information, after applied the clock speed agreement, the current time of all clients will be fetched by the server. Here the all client time information will be same. So the server is now ready to communicate with the clients. Once the time information fetch, the clients will be running at the same speed and having same time. So it will be very easy to listen the log information during the client server communication. Electing nodes to send data. The server will elect the client nodes to send data to those are selected. The router will be listening to both the server and the clients and maintaining a log information about the communication between the server and the clients. Finally, the log information will show that we have achieved the accurate synchronization and have improved the scalability of flooding. The data flow diagram contains two levels, that is level 0 and level 1. In level 0, server is connected with the clients. The client number of number of clients, and the client sends the request, whereas the server accepts the client's request. The server is always waiting for the clients, so that when the client send the request, the server will accept the request from the client. In level 1, after accepting the client's request, the server will synchronize the client's time, that is which one is first requested, and the sending clock speed agreement. In screenshot, the home page is here. The time synchronization based on slow flooding in wireless sensor network is that project title, and we are going to synchronize the time in this wireless sensor network. Next thing is path reconstruction algorithm. To construct the shortest path from the source to destination. In second, that is method 2, the construction of shortest path from source to destination. In the method 1, it is connected with the shortest path, and in method 2, the construction of shortest path from source to destination is then connected with the shortest path. In method 3 also it is connected with the shortest path. In the above three methods, which one is the shortest method to construct the path from source to destination? In the file transform, the file sharing is done. After the file is transferred, the file is shared via wireless sensor network, and the file is encrypted. The encrypted file is now sent along with the wireless sensor network, and the file sent successfully message is obtained. After that, it will calculate the time to send the file, decrypt the file. It will decrypt the message, that is encrypted message is decrypted, and the performance graph is also here. Computing times in the three methods, first method, second method, and third method. The computing times of all three methods is here. Encrypted file location is given here, and the decrypted file location is also given here. And the conclusion about this project is, in this study we considered the question of whether it is possible to achieve the scalable and tight synchronization in WSNs with slow flooding. We emphasize that the performance of drift estimation mechanism is vital for flooding based time synchronization protocols. We pointed out that waiting times due to slow flooding with multi-hop least square drift estimation amplifies the estimation errors at each hop. Our experiment on the line topology, that FCS aim, proves the performance of GTS remarkably and outperforms FTSP by a factor of 26. Moreover, FCSA catches the performance of pulse synchronization, the line topology, and it is superior on the grid topology. Finally, we plan to evaluate the performance of FCSA in synchronization to the real time. Thank you.